Hey guys, here we go again. Now we're moving into logarithmic functions. This is a really cool move into the future. We're starting to look at things we haven't seen before. We're starting to analyze certain things in different forms, and that's basically what we're trying to do here. We move in mathematics into analyzation mode. We're looking at these graphs and we're analyzing where these graphs have moved and what they show and what their domain and range is. And so now we're just going to look at something that's called a logarithm. A logarithm is just a different form of exponents. It's just showing it a different way. It's putting it together. Now, the best part about logarithmic form is that we can take something that's not in logarithmic form, put it in logarithmic form, and perform some easy mathematics that would get us to a certain answer that we couldn't normally get, putting some sort of function into a calculator to get what we need. Now, logarithmic form has some sort of base. It's a log that has some sort of base. All right, and it has some sort of exponent. But it's a base, an exponent, and what you get when you evaluate it, right? It's your answer, all right? Well, in logarithmic form, you take that same base, right? And you put your exponent out here, and that's what you get when you evaluate it. So, for instance, here you go. Log 3 to the x is 27. Sorry. Log 3 to the 27. Oh, we don't like 27 because it gives you the same number. Log 3 to the 81 gives me 4, right? And what that means is 3 to the 4 is 81, right? So that's basically what it is from log form to exponential form. Some really cool things that you should memorize. I know they told you before when they started dumbing down mathematics, which is why we're having so much trouble, why we're going so slow. Don't memorize. Whatever you do, don't memorize, because memorizing doesn't help. They lied to you. Memorization is key. If you can get used to seeing identities, things that you see all the time, that you can get used to, all right? Here's what it means. This says if you have anything, any base, and your answer is 1, well, duh. The exponent had to be 0, because anything to the 0 power is 1. All right, that's a real easy one, right? Okay, your base and your evaluation are exactly the same. Well, then your exponent had to be 1. Duh. Let's just say log 7, 1 is 0. Well, yeah, Sokol, 7 to the 0 power is 1. Well, let's use 7 again. Log 7, 1. Well, of course, Sokol, 7 to the first power is 7. We're getting this, right? This is the same idea. So, the base right here times the exact same thing. Here, now we're moving into something else. All right? There are different types of bases. This is log base 5. We're going to get there. All right? So if your b right here is the same here, but this also has an exponent, then this and this are an identity, and they equal 1. I'm going to show you where that shows up down here. This is also true. Log base b times that b is the same thing as this. and this also equals 1. So when you see it, what's left over? Duh, the x and the x. Well, of course x equals x, Sokol. It can't equal anything else. I know you're saying that. I know you think I'm crazy for telling you something that you can actually see and understand. I just need you to know it. So I apologize if I'm saying something that's absolutely silly, but if you can memorize those ideas, because we're about to see those ideas in action when I get this little pen thingy out of my pocket and start moving down the line. All right? You don't know this, but you're about to know this. The other thing we need to know is that the natural log times e is another identity of 1, right? E is the base of the natural log. So when you multiply the natural log times e, you're basically canceling it out, and 7 equals 7. All right? Oh, look at that. That equals 1, right? This, same idea, equals 1. This, same idea, equals 1. So 5 equals x, 5 equals 5, 5 equals x. Same idea. Here we go. 10 log. This is the new one. Any log that doesn't have a base is our common log. Our common log is 10. I know it sounds goofy. I know I'm giving you a lot of information all at once, but that's why I put it in video form, so you can watch it again. Or you can look at some papers and understand this. I'll put both the study guide and the practice sheet on the homework so you can see these identities in action. And then again, when we multiply our common log, which is log base 10, by 10, what do we get? We get 1. We get 1. If we get used to this, we're gonna be able to go crazy and figure this out. All right? Look. Log 7 times 7. What does it equal? 1, Sokol. That's what it equals. Here we go. 10 times log base 10. That's our common log. What does this equal? 1. All right, what's left over? 5x. 5x. That's all there is. We're done. 3 times log base 3. What does that equal? 1. What's left over? 2. This is pretty darn easy, isn't it? Oh no, we have something difficult. Just kidding. Just kidding. All right, you ready for the fun? I have a log here. I want to rewrite this in exponential form because it's going to be so much easier. This is 6 to some unknown power equals 36. Oh, God. I'm so sorry we had to do this. So x has to equal 2, right? I know there's no x there, but this evaluated has to equal 2. All right, I'm in base 3. Oh, my God. 1 over 81. What do you mean? Well, let's start thinking in terms of powers. I know I'm going to rewrite this in exponential form. 3 to some unknown power is going to equal 1 over 81. Well, I know because I'm smart, and you know because you're smart, that an exponent that is negative gives me 1 over that number, right? Right? We know 3 to the 4th is 81. So we say 3 to the negative 4 is 1 over 81. So this evaluated is negative 4. If you put it in a calculator, you can get it. I'll show you how to do that. And last but certainly not least, here we go. These two things, when put together, when multiplied together, what do they equal? Dear God, Sokol, if you say 1 more time, equals X squared. Well, if x squared is 1, then x is plus or minus 1. All done. That's pretty much it. We've got natural log. This is the same thing as PERT. We just decided to use the natural log instead. Don't worry about this so much. I want you to get used to these identities of 1, 1, 1, 1. Excellent. All right? Just take care of the practice. You should be fine. Sometimes you got to put it in exponential form to get there. That's all there is to it. Thanks for showing up.